Hello everyone, welcome to my technology channel. Today I'm pleased and happy to welcome Markus Rütering. Markus works as a head of sales for company Laserline, and Markus gonna talk today about high power lasers, laser cladding market trends, and general developments related to laser surface engineering technologies.
And I'm very happy and excited to introduce you Markus, who is working as a director of sales and marketing at Laserline. A couple of words about Markus himself. He has studied physical engineering, so he has an engineering background, and he has worked in R&D at Rofin, already starting from 1989 as an engineer. And after Markus somehow has felt that he feels more comfortable with sales and moved as a sales engineer, stayed with Rofin, and in 2011, if I'm correct, you have joined Laserline already as a director role. Markus, very welcome from my side, and maybe you also want to say a couple of words additionally.
Yeah, first of all, Arkadi, thanks very much for having me. I mean, I just understood it's the first interview that you're doing on your YouTube channel, and you have chosen me to be your first guest. It's a big honor. Thanks for that. I think together we can create hopefully quite some interesting content for the people watching your YouTube channel. I watched all the videos you did so far, very interesting, and thanks for pushing this topic. I mean, we also believe in laser cladding, we love laser cladding, and so we can do these things together. Yeah, basically you were very correct in your description. Maybe the only thing I can add is I possibly didn't fail in engineering, as you pointed it out. I was forced to move into sales, to be honest. And in the end, I'm quite happy with it. So over time, technical background and technical sales, for me, a very good combination. Again, thanks for having me. Let's kick it off.
Yeah, thank you, Markus. Probably for people who hear us and watch us, maybe it would be interesting to introduce Laserline first and tell a couple of words. What is Laserline about?
So Laserline is a company going to be 25 years old this year. We are making high power diode lasers specifically for applications in the field of heat treatment, laser cladding, laser welding, laser joining in general, laser brazing. We do some special stuff for carbon fiber reinforced plastics. We have recently launched lasers with the blue wavelengths, so at the visible area. Cutting a long story short, we are the #1 laser maker for high power diode lasers. We are roughly 350 people globally and growing every year. And also the forecast for 2022 is quite promising, but we have to work hard on moving it forward. So basically a company doing laser sources, knowing laser applications, but we're not supplying turnkey solutions. This is done with partners who are supplying these systems to the customers. But we qualify the processes, and I think that's an important point, that we know the laser technology, but we also know very well the laser processes.
Which is an important argument, because there's not enough of knowledge about different laser processes on market. So if you not only sell lasers, but also support people with application development, as probably I would call it, that means you have basically a very good chain to cover market needs.
That's, I think, a very important point. Yeah, we develop applications. That's absolutely correct. People come to us and ask, hey, can we do this? Have you tried that? What happens if we do that? All these things happen here in our applications lab every day. And it's very, very fascinating what ideas the customers have and how the solutions sometimes look.
Yeah, what surprises me, how does customer come to a laser source? I mean, like, I had a couple of discussions previously. Usually if customer has a wish, then he comes to a job shop, so end user, and says, can you do me laser cladding or laser cutting? But working directly with a laser supplier, how comes?
We see both. We see people who have been working with a laser job shop first, and then the possible application is growing. They need more parts. They develop the process not only for part number 1, but for part number 2, 3, and 4. And then the volume is growing bigger, and they have a business case. And based on the business case, they talk to the laser manufacturer and they invest into a machine. Some other people have a business case from the beginning. When it's obvious that we are talking hundred thousands of parts, if we are talking big areas, square meter after square meter after square meter, where it is possibly not capable of covering that with a job shop, they come directly to us. I would even say that based on our marketing, based on the exhibitions and everything we do, more customers are coming to us directly, and some customers come to us via a job shop.
Okay, very interesting. Markus, can you tell me, how do you feel laser market has developed in the last decade? Because I mean, like, I'm still a young person in these terms, and I remember when I was still a student, everybody was speaking about CO2 lasers back to early 2000, and nobody was speaking about diode laser. You had a coherent doing some things, you had IPG starting, and suddenly Laserline 25 years ago came to market. So what do you believe, how laser market has changed in the last decade, let's call it like this?
I think when we look at the names you mentioned, we should not forget Trumpf as another important player in this market, and in the past also Rofin. The technologies that we are talking today are all based on diode lasers or laser diodes. Yeah? I call a single component a laser diode, and the combination of that as a working tool I call a diode laser. It's my personal definition. So a fiber laser, a disc laser, and many other laser technologies are based on diode lasers. Oh, in my own definition, I have to correct myself, on laser diodes. Yeah? So laser diodes are the key, and Laserline from the beginning has said, why should I use the laser diodes, put the light into a crystal or a fiber and convert it when I can use the light straight onwards to the workpiece? And yes, when we started 25 years ago, the laser diodes were on a poorer level in terms of power, lifetime, and beam quality compared to today. This has developed quite a bit. And when we started, the first Laserline was 500 watt, the second was 1 kilowatt, and then we came to 3 kilowatt, but we had big spots. And with this, we did heat treatment on surfaces. Nowadays, our power goes up to 40 kilowatts and higher for industrial products. We have beam qualities where we focus it into a 600 micron fiber. We have more or less substituted lamp pump lasers by our technology about 12, 13 years ago, started to do this. So it's a development in the laser diodes and corresponding from that into the diode lasers. So we are definitely a disruptive technology, confirmed to, you mentioned the CO2 lasers and some other lasers, which we substituted. A very important example, a lamp pumped laser had a wall plug efficiency of 3% and had a power of, example given, 4 kilowatt, was doing some welding applications. We do the same today with the diode laser, but with a wall plug efficiency of 35, 38, 40% plus. Our lasers reach up to 50% wall plug efficiency. And we are talking about climate, we are talking about global warming. So energy efficiency is a very important point also in production. And this is why the lasers have been developed to further and higher wall plug efficiencies. And the diode laser is the top player in this class. There is no other laser more efficient. And this has pushed the laser market towards these technologies.
Markus, that's quite exciting. But if to make a short summary, what are the main three advantages of diode laser? So it's efficiency.
Efficiency definitely is very important. The second is the wavelength. Diode laser has a wavelength in the regime between 900 and 1100 nanometers, which has a high absorption on almost every metal. What we have to exclude is copper, but for the copper we have done the blue laser, which has a better absorption on this material. So I can close this gap immediately with the latest innovation that we have put into the market. And last but not least, for many, many applications, it's important how the energy is distributed in the focus. And the diode laser creates what we call a top hat focus. So rather than having a Gaussian beam, which has all the energy or a high energy in the center, and you have this Gaussian distribution, we have some sort of a cylinder top hat power distribution, which allows you a very, very nice melting of materials and very nice heat treatment. And coming back to cladding, which is more or less your topic, the top hat beam allows a wonderful cladding with a reduced overlapping from line to line, which we do with our cladding heads. So this is one of the reasons, and I'm sorry if I take a question up front here, but this is the reason why diode lasers are also so much into laser cladding.
Yeah, it's okay. So summarizing, it's efficiency, wavelength, and also top hat profile. So I mean, I can only agree with this.
Yeah, I would say these are possibly the three most important points, but there is many others depending on the application.
Yeah. So Markus, what do you think? Where you mostly sell, or for which laser technologies do you mostly sell your lasers? Is it cutting, welding, or a cladding side?
We don't do cutting in 2D flatbed machines at all. We leave this to other players in the market. So our major applications are cladding, are joining, means laser welding, laser brazing, something like this, and heat and surface treatment. The number one application we sell our diode lasers is laser cladding. Yeah, it's the biggest application that we have. It is also a very fast growing application in terms of where we sell our lasers. Laser cladding is the most important application today. And honestly, I don't see a reason why this would change in the next 3 to 5 years. There's so many applications coming which need lasers for cladding surfaces, for repair, for changing the surface capabilities, and other applications where you have to have something non-magnetic. You know the applications better than me, but laser cladding is our number one, and it will grow further.
Which is a very important note also for me and for people probably who are going to look us at our interview, because I mean, like, always a question, is there behind laser cladding more than just a scientific approach? Is there a market behind? And you hear, Markus, Laserline is selling most of their lasers nowadays to laser cladding processes, which I'm very happy to hear. Can you do some sneak peeks about number of laser sources you usually sell per year? Is there any official information you can share or not?
We try to be a little bit secretive on this, but we sell several hundred lasers every year. Our factory has a capability easily of 1,000, so we sell more in the future. That's not a problem. But I try to have a quick look. It's more than 30% of what we do goes into laser cladding, and it has been in the recent years, and it's growing.
Yeah. So, I mean, like, and that's where I wanted to ask you, how do you see the laser cladding technologies has changed the laser market in last years? What do you think, how big is the laser cladding market nowadays? Do you have some feeling about what we talk about? And what do you think is the growth of laser cladding technology? Was it always for diode lasers that laser cladding was a major selling argument for diode lasers?
Starting with the last part of your question, I think diode lasers have been picked over time more and more into these markets. I mean, when I say cladding market, I also consider additive manufacturing with DED into this market. For us, it's basically one approach where people use powder and wire to do something on surfaces and build parts and such. So with an increase of power, with a reasonable beam quality, fiber diameter, spot diameter, diode lasers has taken this cladding application more or less in the last 10, 15 years, more and more. I'm not saying it's impossible to use a different laser. And if you speak to the other laser companies, they will tell you, of course, their laser can do cladding, and I don't deny that. But I'm very much convinced the diode laser is the better tool based on the 3 top arguments we were exchanging earlier. So the size of the market, that's really I would say it's a tough question. When you look to analysts who are looking to these markets, they forecast something in the range of $600 to $800 million in about 10 years from now. Nobody has a clear number how big it is today. I personally foresee a growth of 10 to 15% on a yearly basis. So you can calculate backwards from the 800 million where we are today. But as you said, I have a look to the lasers, laser sources, maybe laser machines. I don't have a real look to what is sold as a job shop. I mean, if somebody has bought a laser machine off as a job shop and he quotes square meter after square meter to customers, I have no clue how big this market is and how many million of dollars are used here. And on top of that, powder is not my business. But several $100 million is the possible market size when we take everything into account, yeah.
Yeah, which I would probably give in that range as well. What I'm worried about, what means worried? We hear some rumors about China, and I had a couple of discussions with my colleagues who work with China, and they told to me that already nowadays there are more than 2,000 lasers for laser cladding sold inside the Chinese market. Do you believe this is a rumor, or it might be possible? And how is it for Laserline? This shadow of China and the laser manufacturing. Do you see that as a risk?
Well, I mean, you can see a competition always as risk, or you can see it as a challenge, or you can even see it as a support. I mean, we are basically happy that others are playing the same melody in terms of laser cladding. Yeah. If we would be the only ones stating laser cladding is interesting, possibly nobody would listen to us, but having many people saying laser cladding is interesting, so take it as a chance to grow the market and take your share of the pie. It's true that Chinese laser companies have had a quite big push in the recent years, also based on fundings that they received from Chinese government, as far as I understand. It's hard to compete with companies that are subsidized a lot. Nevertheless, the Chinese market is for us a very interesting market and also a growing market. Why is that? When we look to one of the major branches, it's mining industry. Yeah? I mean, maybe it's an industry which has its limits. Yeah? Coal is not going to be the energy source for the long-term future, but today it's the energy source. And coal mining or mining of other components, we even can mine lithium. It's a very important component in the actual situation with electromobility. But mining uses tools which are reworked and manufactured with cladding, where you have wear-protected surfaces where you can repair these tools. And the typical laser power in China to do this today is 10 kilowatts. And when we look to the general market in China, also Chinese laser companies producing a 10 kilowatt laser with a reasonable capability of laser cladding in terms of wavelengths, in terms of beam profile and everything else, that's not so easy. And I think, I'm a little bit biased to be honest, and maybe also a little bit arrogant, but the 10 kilowatts is something that we established in the Chinese market. And when you speak to people, many say, yeah, what you need is a 10 kilowatt laser. And even people saying what you need is a 10 kilowatt Laserline laser. I mean, I'm quite proud about what we achieved with also our local team there. Everything works as a team. Nobody can do this alone. It's a growing market. Others will take their market share. For us, it's important that we grow, possibly bigger than the market grows. And so far, we are quite happy. Yeah, others joining into the play, you can't predict, and it can give you a push. Yeah, take it as a challenge, take it as a chance.
Interesting that you have mentioned, especially in direction high power. And actually, let's discuss here a little bit deeper. You say high power starts for you from 10 kilowatts. I know there are a couple of your lasers already operating on the market with 20 kilowatts or even more energy. Some institutions have 40 kilowatt lasers. What do you believe is the future of laser sources for laser cladding? Is it high power or is it a high speed, which is like very now known under the marketing term ELA, extreme high velocity laser cladding?
I think we have to consider a term a friend of mine used a lot in the past, the horses for courses, the right laser for the right application. Let's pick the point of high velocity laser cladding, high speed laser cladding. Typically for very thin layers, I would have said 3 years ago, this is an application for a 2 kilowatt laser, maybe for a 3 kilowatt laser. Today, I tell you, this can easily be a laser having 15 kilowatt or having 20 kilowatt. It's a matter of having the right spot size, energy density, powder supply, and speed. And if we talk about a high number of square meters, it is not that we try to do it with the smaller spot sizes that was first published and very well recognized by Thomas Schophofen and his team from ILT, but it was developed further, also in Aachen. Yeah, that's not the point. The kickoff was with the 4 kilowatt laser. Even the laser they used to establish this application was a Laserline laser. Sorry to put it here as a side mark, but high-speed cladding, thin layers, today easily done with 20 kilowatts, 15 kilowatts, whatever. Yeah, high-power cladding so also can be something for thicker layers with a shorter time, or typically people say how many kilograms per hour. The possibly unofficial world record that I have seen was 35 kilograms per hour of an Inconel 625 applied at IWS in Dresden with our laser. That time they used a 50 kilowatt prototype. And they have installed now a 42 kilowatt laser from us to develop further processes, optics and components for these high powers. 20 kilowatt for me is a clearly established industrial product. That doesn't mean everybody who wants to do cladding needs a 20 kilowatt laser, don't get me wrong. Yeah, I would say a classic laser for laser cladding today is a 6 kilowatt laser. People are trying to get more power, higher speeds. The prices are slightly dropping. And so this shifts slightly more and more to more power. So it was a 4 kilowatt laser some years ago. Today it's a 6 kilowatt laser, and it will move forward.
Tomorrow is a 10 kilowatt laser, Laserline laser. But I mean, I agree with you. And basically, I also mark this trend, and it's also good to know. However, as a practical user, my main, let's say, point of concern is related to the fact of back reflections, long-term usage. How can you handle this massive power which you get with 20 plus kilowatts in the, let's say, industrial conditions, working 24 hours with your laser cladding equipment on many components? Do you believe there is some work done, or there is more work required for that?
That's a very interesting and also very good question, Arkadi. Today, the applications that run with 20 kilowatts are maybe not yet 24/7, but they are getting there. Yeah, we have customers working 24/7 with 20 kilowatts already. The main point is to create the process in a way that the power is absorbed in the powder and the workpiece rather than back reflected. So the amount of powder fed into the melt pool, the spot size, speed combination, these must match. And then you can also create powder efficiencies in the range of 90 to even possibly 95%. So by far exceeding what we know from thermal spray, also making it an interesting business case again, because you save the powder. Sorry to say for Oerlikon, I know you want to sell more powder, but
I'd rather better sell 20 tons of powder with 90% efficiency, knowing that the powder brings the parts forward rather than the 50% of losing powder. Because in my opinion, personally, it's not environmental friendly. Even if you make money, but making money with not environmental friendly process, and also having powders overspray or which cannot be reused, it's not a good sign. So I believe laser cladding, that's why is a green process, and which in my opinion is again one of advantages of it.
I totally agree. Yeah. not only long term, but already medium term, the processes that are green, basically greener than others, will survive. Yeah. When we look to what customers ask us today is, how much energy do I need to do this application? But they take it even further. They ask us, how much energy did you use to produce your laser? Yeah. And of course, how much energy is used to produce the powder, and how efficient is my powder usage in the process is very important questions. So your statement is totally right. Yeah. Coming back to this back reflection issue, it's not an issue to the back reflection question. So having the process set in the right way, having applied the power and powder in the right combination, speed and everything else, there is not so much back reflection. Yeah? The power is absorbed into the powder and the base material. It's never reflection free. But it's not that you have a 20 kilowatt laser, you put 2 to 3 kilowatt in powder and application, and 16, 17, 18 kilowatts are somewhere in the room. That would be very inefficient. So we have a chance of couple most of the power into the application. Yes, you have some heat reflection, because we are talking about molten nickel, we are talking about molten steels and whatever coatings, and they have a heat radiation. For this, we have to deal with cooling. That's fine. But it's not that you have laser power somewhere in your room and making things broken or having issues. Of course, you need a laser safety enclosure. This is a standard, nothing different than what you do from laser cladding or laser welding. But nobody should be afraid that everybody has something like a weapon which is out of control when going to high power. It's absolutely not the point.
Yeah, I mean, like you always can see a clearly trend between big companies where this laser safety on such a high level, there's nothing allowed. For example, also working for Oerlikon, I'm not allowed to enter any type of my systems during the process simply because of laser safety, robotic safety, and whatever. If you go, however, in the small job shops, especially located outside of European Union, you quite commonly mark people just putting glasses on, going to a room with an operating 20 kilowatt laser. Do you believe this is a high risk? I mean, like I personally have done it also a couple of times or many times, been an engineer many years ago. Has some things changed there?
Maybe some people are getting a little bit less afraid over time, and I'm not supporting this, to be honest. Yeah, I mean, I'm in laser industry since 32 years, and I've never been in a room with an open laser beam or open laser process without safety goggles. Never.
Clear. And safety first.
Yeah, and I only can tell the community listening here, don't do it. Yeah. The risk of getting harmed in terms of the eye is not high, clearly. Yeah, and getting harmed on skin or whatever, there is no risk. I know one person that took it too easy, and this person is blind today. So take this as my clear remark. Safety goggles when you are in a room where the laser is operating is a 100% must. Yeah, and I hate videos on YouTube or wherever where people are having lasers around and no safety goggles. Yeah, safety is nothing to be ignored, but at the same time not an issue where people should be worried about. It's everything can be handled easily. Yeah? We run up to 60 kilowatt prototypes here in our company. And we are not industrial, so everything is a little bit more open, it's a little bit more engineering, and never ever anything happened. Yeah? It's not to be ignored, again, and let me state this, safety must be considered, but it's nothing to be afraid of.
Just follow the safety rules, as usual. And that's the point. Good. Markus, another topic, you have mentioned it already, additive manufacturing. It's a really huge hype on the market happening by additive manufacturing. Do you see that people who approach you, especially for DED or directed energy deposition or laser metal deposition, there's so many names for that, they recognize that laser cladding is basically also an additive manufacturing technology?
Absolutely. And look back to the recent Form Next exhibition in November 21 in Frankfurt. Luckily, the point where we last met in person, right? It's officially an exhibition for additive manufacturing, but 50% of the discussions I had on our booth was about laser cladding. So for me, the Form Next exhibition to some extent is an exhibition where we talk about powder and wire applications by laser and other technologies. And this can be for surface treatment, surface development, cladding coating, and it can be for making a part. Making a part today is done typically in either the powder bed fusion or in DED, if we take the official term, as you mentioned it already, direct energy deposition. Some still call it blown powder, laser metal deposition. Yeah, there's many different things. I'm talking about a laser with an optic, a powder nozzle, powder used to create layer by layer by layer into a part. And typically I would refer to as DED today. And many people talk to us about this topic. Go ahead.
This leads me to the next question. I mean, like, first of all, we have to, in my opinion, as an expert, the difference between laser cladding and DED is only one. You don't have so much of influence of substrate. But it's again also not always correct, because using DED, you also have to think about deeper how your process and fixturing for substrate look like, because you need somehow to take the heat away. Yeah, but that's not my question. It was just a remark. The question is following. You mentioned Form Next, and typical additive manufacturing exhibition, very popular. I've really enjoyed to be there. And at the same time, however, there is nothing dedicated to laser cladding or surface engineering technology existing on market where laser cladding would be in focus. We also have to agree that the laser cladding is developing. However, it's not so well established and industrialized as a thermal spray. What do you believe is the main bottleneck points in the development, and how we can change this fact, especially knowing that Laserline is selling more laser cladding devices? What would you recommend from that point of view?
Well, that's a tough question, Arkadi. I mean, of course, the easy answer would be let's establish a laser cladding exhibition. I'm not sure if this is the right approach. Laser cladding could definitely be a topic which is more covered in conferences sometimes. Yeah, when I look to conferences for laser applications, I read femtosecond, picosecond, ultra fast lasers. Yes, we do a lot with the new wavelengths, blue and such. But having a reasonable discussion about laser cladding, it happened in Dresden on their conference recently. I think you did a speech, if I'm not totally wrong. And that's for a reason, yeah. They are really a hotspot for laser cladding, together with some others, also on a global approach. The community is not very big, well informed, but growing. A simple exhibition would be too short. Making more noise in terms of conferences, discussing new applications, etc., I think is more interesting. Yeah. So on the next bigger event would be the conference in Aachen in May next year, the AKL. Honestly, I have not looked to the program yet. Don't even know.
You will find my name there as well.
Okay, that's good to know. Yeah, I wasn't sure if the program is already out, but this is something to spread it. And of course, an exhibition like Form Next, if I can speak to their managing and marketing team, I would tell them, yeah, push the additive point, but don't forget about surface engineering as well, because it's so well established meanwhile in the Form Next exhibition. Yeah. We have our samples were 50-50 between laser cladding and additive manufacturing. The lasers and tools and whatever we showed was somewhere between 50-50 for the both processes. And maybe if I guide us to one of the biggest topics at the moment, yeah, laser cladding of brake discs. This was a very hot spot in Frankfurt on the Formnext, and it's not additive manufacturing. It's adding material to a substrate, but it's not additive manufacturing in the classic approach. Nevertheless, it was one of the hot spots in this exhibition. Yeah. So it's a mix of marketing like always, but simply asking for having another exhibition for laser cladding might be not enough.
Yes, I believe you are right. We need more marketing, especially by companies like Laserline, you mentioned Trumpf before, and others, simply by the fact that more we speak about technology, more interest we can achieve. However, in my opinion, and that's where I would like to hear your remark as well, I see the bottleneck in following. First of all, we don't have enough laser cladding experts on the market. So means process understanding and laser cladding is not an easy, especially a DD process where you have to model 3D parts as well. Understanding of altogether is still very on a low level compared to thermospray. Additionally, many companies and many market segments still struggle to change to new technologies because they say, why should we change if we have already thermospray or we have PTA running there for 20, 30 years, we have it in our specifications, and to change the specification, how we can put more norms to laser cladding. Those all questions are still, in my opinion, quite in the baby phase and need more and more attention to make laser cladding make this big step of being to couple of 100 million business to couple of billion business, which I believe it's totally feasible.
It's absolutely feasible to talk about such a big size of the market in the future. And I think what we simply see is something we have seen in the past and possibly hard to change. They give you two other examples. My first job in sales was selling laser marking systems in the 90s. And when I visited companies that time, their drawing said needle printed 0.4 millimeters deep. That was a simple saying on the drawing, and the drawing was approved for production, and it was possibly production of a big car maker, and changing that 0.3 millimeter deep to something else was more or less impossible. Everybody knew laser marking is definitely temper proof, can't be changed, whatever. But the drawing said 0.3 millimeters deep. Heat treatment, also for diode lasers. Yeah, many people use heat treatment in terms of induction heating or high frequency heating, whatever you want to call it. And the drawing easily said heat treated 60 HRC 3 millimeters deep. Why is it 3 millimeters deep? Because induction heating can't take it a little bit less reasonably, and you need to rework the surface after the treatment of induction heating, and you needed to take material off to have the surface measurements you wanted. With laser hardening and laser heat treatment, there was no need of doing a rework of the surface after the laser did its job. So having a depth of 1 millimeter, which is classic for laser, maybe 1.5 at sometimes, is absolutely enough. But the drawing said 3 millimeters, so people didn't want to change. Luckily, for one of the most important things here, European Union, respectively, a governmental approach has helped us. Hard chrome is more or less banned. You need a specific license to run it. And the high-speed laser cladding for thin layers, you refer to it as EHLA. Personally, I prefer high-speed cladding because there's many different approaches to it. Can definitely substitute this application. And under the pressure of people having the need to do something, we can push it forward. I agree, it will take some time. Standards have to be changed. This is a long process. You can't do this as a disruptive technology within a year or two. It takes a decade. And we are working on that. Yeah? I want to sell lasers also in 10 years from now.
I wish it will happen. And I wish in 10 years we meet again at Formnext and you sell already not a couple of hundred lasers, you sell a couple of thousand lasers and still successful, and mostly with 40 kilowatts having industrial processes. Anyway, Markus, before we finish, maybe you want to summarize what you said. Maybe you want to wish something. Use this time, because I mean, like, Laserline is a well-known company in the laser cladding market, and I really appreciate having you here and giving your insights. I believe it was very interesting. Also for me, I learned a lot of things, and thank you for that.
Yeah, first of all, again, thanks for having me. It was very nice to have the discussion. I mean, some of the discussion we have had even in private and personal meetings, but having it on a bigger scheme and even asking me some more detailed question was very interesting as well for me. So thanks again. Summarizing, I think what we can state is laser cladding is definitely a very industrial application. People who think laser cladding is somewhere a niche application, I don't agree. It's not as big as, I don't know, laser cutting in terms of numbers, yes, but it's no longer a niche application. The demand of the customers in terms of process support has never stopped. You develop new powders at Oerlikon. People ask us what they can do with these powders. So this will go on. Powder efficiency will be pushed forward. There is still a lot of stuff that we can discover to make the market bigger. Power levels, I think overall in average will increase, and I'm 100% convinced the diode laser technology will be the one dominating this market in the end. It is more efficient than others, it's more green than other technologies, well suited for the application. And this is why I'm convinced we are going to have success with this. And let me say, this is also one of the reasons why I'm at Laserline. Very simple.
Very good. Thank you, Markus.
Arkadi, thanks for having me. Enjoy the rest of the day, and I'm looking forward to meet you again.
Once again, thank you to Markus and to Laserline for this interview, for an open discussion, and for providing me those exciting video materials which give you an idea how the laser cladding technology is developing and what a major role diode lasers play there. I also thank you, my dear viewers, for watching this video. And I want to ask you to add your questions, add comments, maybe you have some interest. Please feel free to reach out to me, to reach out to Markus. His contacts will be also in description to video. And let's develop a laser cladding market together.